Today's notes are about factoring by grouping, but first we're going to review the things we already know. So the things you know are to look for a GCF, and if you have a binomial, which means two terms, you should look for a perfect square minus a perfect square. So we're first going to look for a GCF. There is a GCF of 3y. If you divide each of these by 3y, you get y minus 2. If it helps you to go back and show this part so that you get that, that's fine. You don't have to. That's your answer. You have to have the 3y out in front. Here, if you look across, the largest number that divides into all of those is 2, and they all share an x. If you think about dividing here, you get 3x squared. If you think about dividing there, you get minus 2x. And if you think about dividing here, you get minus 6. Make sure you have the 2x out in front. Here the GCF for these two terms. The largest number that divides into 14 and 18 is 2. They have an a to the 4th in common and a c in common. When I look at this division, I'm dividing 14 and 2, and the a's cancel, and I get c squared. And here I get plus 9, a, b to the 3rd, the c's cancel. We're actually going to see this part again today, but for now what we're looking at is these, and they have a x plus 7 in common. And what's left, if you ignore the x plus 7s, is a 4x minus 1. And if you wish to write the 4x minus 1 first, and the x plus 1 second, or x plus 7, sorry, second, that's fine. So here what these have in common is a 3x minus y, and in the other parentheses will be a 4x plus 1. You have to have them in parentheses. Here what they have in common is the e plus 1. If you cover up the e plus 1s, what's in the other parenthesis is e minus 4. This does not have a GCF. This fits the pattern of a perfect square minus a perfect square. It factors to x plus 15, x minus 15. This does have a GCF. It's a GCF of 5. If you factor out the 5, you have a squared minus 4. And this is now a perfect square minus a perfect square. So you leave the 5 out in front, and you factor the a squared minus 4 to a plus 2a minus 2. This one you need to be careful. It's really easy to turn this around to m plus 6 and m minus 6, but that is not correct, because you're saying 6 and negative 6 multiplied to positive 36, and that does not work. The 6 has to be first, and then plus m and minus m, because these two have to multiply to a negative m squared. Here you have b plus c, b minus c. Let's see, 7x times 7x is 49x squared, and 12y times 12y. And I need a plus and a minus. By the way, I did look for a GCF on these. I did not see it, but here I see a GCF of b. So when I factor out the b, I have a squared minus 400, and I have a plus 20, a minus 20. You ought to stop the video and do the bottom part of this and make sure you know they're actually in the same order, so you can look up at the corresponding problem on the top and make sure you know this review, because we're going to keep adding more to factoring. So here's the answers to the bottom part. Check and make sure that's what you got. And then we're going to move on to the next page. So the next page is what's called factoring by grouping, and it can be identified because it has 4 terms in it. And honestly, you can do factoring by grouping with more than 4 terms, but we're going to stick to only 4 terms. So here's how the grouping is going to go. You are going to group the first 2 terms together, and you're going to group the second 2 terms together. And we are not going to have to group them any other way. It's always going to work to be the first 2 and the second 2. So when I look only at these first two terms, I'm looking for a GCF of those two terms only, and they have an m in common. And if I factor the m out of there, I get 5 plus n, and that's what goes in here. Now I'm going to cover that up, and I'm going to look for the GCF of these two. And the GCF of these last two terms that I've grouped together is 2, and it's going to be a positive 2. One reason is this, the other reason is everything's positive in this problem. And if I divide out a 2, I have 5 plus n. Now, if you think about it for a moment, you've already seen problems like this. In fact, we just practiced them. You can look at these two things and see they both have a 5 plus n in them. And what's left in the other parentheses is m plus 2. If you wish to write the m plus 2 first and the 5 plus n second, that's fine, but you have to have parentheses around everything. So, the end of that should seem familiar, but how you start is recognize there's 4 terms. When there's 4 terms, we are going to group the first 2 terms and group the second 2 terms. When I group the first 2 terms and look, their GCF is 3. If I divide a 3 out of there, I get x plus y. You do not need to write this 3 here. I'm just showing you. Now I look at the second 2 terms, and they have an a in common, and I write plus a. For one reason, these are all positive, but another is there's a plus right there. If I factor out the a, I have x plus y. And now I can look at these 2 things, and they both have an x plus y in them. And I'm left with 3 plus a. So now we're going to move on to 4. So we are going to just say, look, visually I've got 4 terms in here. 1, 2, 3, 4. I'm going to group the first 2, I'm going to group the second 2, and it's always going to be that process. Another class can deal with rearranging them or having more than 4 terms. But I'm looking at these 2, and I'm saying the GCF, the biggest thing that divides in is 4w squared. And if you divide those both by 4w squared, you get w minus 5. Over here the GCF is 3, but I want to tell you the GCF is negative 3. It contains whatever sign is right here. It has to be a negative 3. So when you divide here, you get w, and when you divide here, you get minus 5. So how you tell whether the GCF is positive or negative has to do with this sign in the middle here. So now when you look, there's a w minus 5 in one of the parentheses, and a 4w squared minus 3 in the other. So 4 terms. We're not doing any other kind of factoring with 4 terms. You're going to just be able to look at a problem and say it's got 4 terms, it's grouping. I group the first 2, its GCF for the first 2 is 2t. When I divide them by 2t, I get 2t plus 3v. And then over here I need to notice it doesn't appear I have a GCF, and that means the GCF is 1, and in this case the GCF is negative 1. When you divide by negative, you get a positive, and same here. So your GCF can be 1, and in this case it's negative 1. When I look here and here, what's in the parentheses is a 2t plus 3v, and what's in the other parentheses is 2t minus 1. If you're wondering if these will ever not match, that'll be a different class, or it means I've made a mistake in the problems I've written. So what I want you to do is turn off the video real quick and do numbers 3 and 6 and make sure you know what you're doing on those. There's the work and the answers to 3 and 6. By the way, if you have y squared plus 4 times y plus 3, that is fine. Those are the same thing. And I'll probably eventually stop saying that, but I want you to understand those are the same thing. So if that went well, good. If it didn't, I wouldn't worry about it. I'd just go on and watch these because you will pick up on it. So I'm going to notice, hey, that has 4 terms. The GCF of the first 2 terms is m. If I factor out the m, I have n plus 2. Here my GCF is negative, and it's negative 5. If I divide these each by negative 5, I get n plus 2. The parentheses match. So in one of these 2 parentheses, you're going to write the n plus 2. And the other one, you're going to write m minus 5, and it doesn't matter which one. So you could just mute me and just like try this one and see if it compares well to mine, because you need to practice some of them on your own. But if you need to hear another one, the GCF here is 7. If you divide out a 7 or factor out a 7, you get w minus z. Here the GCF is negative. It's negative b. When you divide by negative b, you're getting positive w and minus z. You're doing a positive divided by a negative. In one of these sets of parentheses is the w minus z, and in the other one is 7 minus b. So, moving on. Four terms. GCF is w squared. When I factor it out, I'm left with w minus 2w, minus 1. Make sure you know when you divide by w squared here that you get minus 1. You have to have that part. My GCF here is going to be a positive 7 because that sign's positive. And when I divide it out, I get 2w minus 1. Again, you have to do 7 divided by 7 and get 1. And one of the parentheses is going to go 2w minus 1, and the other is going to be w squared plus 7. Here, the GCF, the biggest thing that divides in is 3p squared. And you're left with 6p plus 5. Look here, there isn't a GCF, and that means it's 1, and in this case it's positive 1. And when you divide by 1, you just get 6p plus 5. So I have 6p plus 5 in one of the parentheses and 3p squared plus 1 in the other. So, pause the video for a moment and do number 9 and number 12 and make sure you know how to do those, because the last few are just slightly different. There's the answers to 9 and 12. At this point, if you didn't get these right, you need to go back and look and re-listen and follow, because you should be following along by now. So we're going to start these last ones the same way. It's 4 terms. It's grouping. There's an x squared in each of the first 2 terms and a negative 4 in each of the second 2 terms. And when I divide by negative 4, I get x plus 3. And one of the parentheses is x plus 3, and the other is x squared minus 4. And I now have something that's not done. This is a perfect square minus a perfect square. So the x plus 3 stays the way it is, and it's part of my answer, but the x squared minus 4 has to be factored to x plus 2, x minus 2. So basically, your first rule of factoring is to look for a GCF. Your last rule of factoring is to make sure you've done your job completely and that you don't have a perfect square minus a perfect square sitting in a problem. So let's try that again. So in the first 2 terms, x squared is the GCF. And the second 2 terms, minus 9 is the GCF. And when you make your 2 sets of parentheses, x minus 2 goes in one of them, and x squared minus 9 goes in another one. Now, this is a perfect square minus a perfect square. By the way, it has to be minus. If this were x squared plus 9, you can't do anything to it. So I leave the x minus 2, and I factor the x squared minus 9, and get x plus 3, x minus 3. So now, here's what I said. Let's go back to number 3. This is not a perfect square minus a perfect square. So that stays as my answer. It's got to have a subtract in it. So go ahead and turn off or pause the video and do number 15 and make sure you know how to do that problem. And there's the answer. So the last page, I like the last problems we did last time, only there's more of them. And I want you to notice that they all end in 72 or negative 72. So here's the idea. And you don't need to write anything up here if you don't need to, or you can write as little as you want. I'm just going to look at number 9 for a moment. I'm going to make 2 sets of parentheses. I'm going to put x's in the front, and I'm going to notice that I'm going to multiply to a negative. To multiply to a negative, you need a positive and a negative. You can't have 2 positives, you can't have 2 negatives. And I need these 2 numbers to combine to negative 1. And here's what I know. 9 and 8 multiply to 72, and if I make the 9 negative and the 8 positive, that works. So any of them you can do in your head is fine. The problem with 72 is there's lots of factors. So I'm only going to make one list for 72, and I want to tell you how to do it. Take your calculator, silly as it is, and do 72 divided by 1. And you know that one, but here's the thing. If you use the up arrow, or the back arrow I should have used, on your calculator, now divide by 2. And you get 36. Now if you use the back arrow, you can divide by 3. Here's the thing. You probably didn't memorize your 3 times tables up to 24. Use the back arrow. Divide by 4. Use the back arrow. If you want to divide by 5, it doesn't work because I didn't get an integer. Divide by 6. This was a multiplication fact, but your 12 times tables are not used very often. If you divide by 7, it's not helpful. If you divide, by 8, you get 9. And here's how you know when you're done with the list. If you get back to this number, there's no reason to write 9 and 8 because you already have that one. So there's my list of factors. Now what I need to think about is I could have them both positive, I could have them both negative. So I could add these to 73 or negative 73 if they were both negative. I could add these to 38 or negative 38 if they were both negative. I could add these to 27 or negative 27 if they were both negative. If one was positive and one was negative, I could get 71 or negative 71. And if it helps you for a moment to write that out to the side, you can get any of these by changing the signs on them and adding them together. So that's what you're looking for. And if you want to write that out on this one, you can get 38 or negative 38 depending on the signs. And you can get 34 and negative 34 depending on the signs. Here you can get 27 or negative 27. You can get 21 or negative 21. You can get 22 or negative 22. You can get, 14 or negative 14. You can get 18 or negative 18, 6 or negative 6, and you can get 17 or negative 17, and 1 or negative 1. So it depends on the signs. If they're both positive, you would get this. If they're both negative, you would get that. If they're one of each and you add them together, it depends on which one's positive and which one's negative. So what you need to do is use that information here, or just your brain. If you know it in your head, then you're going to sit and fill these out. And if you want to put in the parentheses first, and then go back and fill them in, that's fine. If you want to write the parentheses in as you go, that's fine. But you are coming up with 2 numbers that multiply to negative 72, got to have a positive and a negative, and are going to give you negative 34. So it's 2 and 36, I can see that here. How I decide what they are is I need a negative 34. So I now know I'm going to use 2 and 36. I need to think about the negative 34. I need the negative 36 here and the positive 2 there. I'm going to multiply to a positive. To multiply to a positive, I need 2 positives or 2 negatives. In this case, it's going to have to be 2 negatives. And to get negative 73, I need negative 1 and negative 72. Here, I'm multiplying to a positive. There's no reason to have any negatives in this one, and I need them to add up to 38, and that's positive 2 and positive 36. And you can have the 36 here and the 2 there. Here I need to multiply to a negative. That's a positive and a negative. I need 71 and 1, but since I need a positive, 72 and 1, since I need a positive, the 72 goes here and the negative 1 goes there. That will give me positive 71. So I turn off the video and I do the rest of them. You will get pretty quick at this, and if you need to look up here, that's fine. And if you don't need to, that's fine. There, thank you.